Imagine a mysterious object streaking through our solar system faster than anything we've ever seen. Not a comet, not an asteroid, and definitely not from our cosmic neighborhood. In 2017, this enigma named Oumuamua turned astronomy upside down. Could it be an alien spacecraft? A relic from another star? I'm Elena Navarro, a scientist who spent years chasing answers in the stars. And from this observatory, my home away from home, we're about to unravel the greatest cosmic puzzle of our time. This journey is wilder than any sci-fi blockbuster, and you'll want to stick around to see where it leads. Let's dive into the mystery of Oumuamua and what it means for humanity's place in the universe. It all started on October 19, 2017 in Hawaii. I was a postdoc then hunched over my laptop when news broke from the Pan-STARRS telescope. An astronomer named Robert Warwick had spotted something extraordinary, an object racing through our solar system at 59,000 miles per hour. Its path was unlike anything we'd seen. It wasn't orbiting the sun like our planets or asteroids. Instead, it followed a hyperbolic trajectory screaming Interstellar. This was a visitor from another star system, the first we'd ever confirmed. My heart raced as I pored over the data, feeling like I was witnessing history unfold. What set Oumuamua apart wasn't just its origin, it was its behavior. Comets leave trails of waste and dust when they near the sun like a cosmic exhaust. Oumuamua was silent. No trail, no glow. Its shape was even stranger, roughly 380 feet long, 364 feet wide, and 62 feet thick like a flattened football or a cosmic pancake bigger than the Statue of Liberty, but with proportions no asteroid or comet could match. That shape haunted me. Most space rocks are lumpy, irregular. Oumuamua looked designed, almost aerodynamic. I couldn't help but wonder, what if this isn't a rock at all? What if it's something more? As we studied Oumuamua, the plot thickened. It passed just 23 million miles from the sun, closer than Mercury, and then did something jaw-dropping. It accelerated, hitting 194,500 miles per hour. That's 5 times faster than Voyager 1, humanity's speediest spacecraft. Gravity alone couldn't explain that boost. Something was pushing it, but we saw no jets of gas or dust. That's when a bold idea surfaced from Harvard's Avi Loeb. What if Oumuamua is a light sail, a super-thin sheet propelled by starlight built by an alien civilization? I was skeptical at first. Aliens, it sounded like science fiction. But Loeb's calculations made me pause. A light sail, just a millimeter thick, could catch enough solar radiation to explain that acceleration. Japan's Icarus probe did it in 2010, sailing to Venus on sunlight alone. Could Oumuamua be a high-tech version from another world? Loeb's team estimated that if Oumuamua is a light sail, it could have traveled 16,000 light-years across the galaxy, surviving collisions with interstellar dust. A journey like that would take tens of thousands of years, too long for a crew, but perfect for a robotic probe maybe programmed to scout distant stars. The idea is bold, but it forces us to ask, why not? We know life could exist elsewhere. The Fermi paradox asks why we haven't seen signs of it, but maybe Oumuamua is that sign. Still, science demands proof, and we're not there yet. So what else could explain this cosmic oddity? Back in the observatory, we turned to more familiar explanations. Some scientists like Daryl Seligman and Jennifer Bergner suggested Oumuamua could be a fragment from a Pluto-like planet rich in nitrogen or hydrogen ice. Picture a piece of Pluto's Sputnik Planitia knocked off by a collision drifting across the galaxy. When it neared our sun, the heat could have vaporized its ice, creating tiny jets that pushed it faster without leaving a visible tail. This idea resonated with me. I've studied icy worlds like Triton, and their surfaces are eerily similar to what Oumuamua might be. But there's a catch. Our telescopes should have detected some gas, even a faint whiff. The silence bugs me. It's like Oumuamua is hiding its secrets. Another theory calls Oumuamua a dark comet, a hybrid with trapped hydrogen that escapes subtly. These ideas explain the acceleration, but they don't fully account for the shape or the lack of a tail. It's like solving a puzzle with half the pieces missing. The natural explanations are more conservative, which is how science works. We lean toward what's known before jumping to aliens. But Oumuamua's uniqueness challenges that caution. It's not just an odd comet, it's a category-defying object. That's why the debate rages on. Could there be another way to crack this mystery? To understand why Oumuamua matters, let's bring this closer to home. I remember meeting Sarah, a high school teacher in Arizona back in 2017. She'd organized a stargazing night for her students when news of Oumuamua broke. Her kids, usually glued to their phones, were mesmerized, debating whether it was an alien probe or a cosmic rock. Sarah told me it was the first time they saw science as a living adventure, not just a textbook. That night stuck with me. It reminded me of my own journey back in 2003 as a grad student. I watched the Mars rover Opportunity land. The idea that we could touch another planet felt like reaching the stars. Oumuamua gave me that same rush. It's a reminder that the universe is full of surprises. Think about the Voyager probes launched in 1907 to study Jupiter and Saturn. They kept going, reaching interstellar space by 2012. Voyager 1 is now 15 billion miles away, carrying a golden record with Earth's music and greetings. What if Oumuamua is another civilization's Voyager? That possibility makes it more than a rock. It's a story of exploration. These stories show why Oumuamua resonates. It's not just about science, it's about our curiosity, our need to connect with something bigger. Whether it's a teacher inspiring kids or a probe carrying humanity's voice, Oumuamua taps into our universal desire to explore the unknown. So how do we chase this mystery further? That's where Project Lyra comes in, a bold plan to catch Oumuamua. Launched in 2017 by the Initiative for Interstellar Studies, it proposes sending a probe to chase this fleeting visitor using gravitational assist like slingshots around Jupiter or the Sun to hit speeds of 74,000 miles per hour. I've worked on mission planning, and this is no easy feat. Oumuamua is already 4.3 billion miles away, racing out of our reach. The probe would need to withstand cosmic radiation and spot a dark, silent object in deep space, like finding a needle in a haystack while riding a rocket. Another idea is a stakeout probe at Lagrange point L2, a stable spot 930,000 miles from Earth. Starting in 2029, it would wait for the next interstellar visitor ready to launch a chase. This isn't just about Oumuamua, it's about preparing for the future. Projects like these show science at its best, bold, creative, and relentless. Even if we don't catch Oumuamua, the technology we develop, solar sails, laser propulsion, radiation shields, will push us closer to exploring other stars. It's a win-win for humanity's cosmic ambitions. But what clues might our own solar system offer? While we chase Oumuamua, our solar system holds secrets of its own. The Kuiper Belt, a ring of icy bodies beyond Neptune, is home to objects like Arakoth, visited by NASA's New Horizons in 2019. Arakoth looks like a snowman formed from two ancient chunks that stuck together. Its pristine state tells us how planets formed 4.6 billion years ago. Other objects like Quasar puzzle us too. Quasar's temperature rose from 360 degrees to 260 degrees millions of years ago, and we don't know why. Could it have been heated by internal processes or something stranger? Then there's Sedna, whose orbit swings so far out it might have influenced comets that hit Earth, possibly even the one that killed the dinosaurs. Studying these objects feels like reading the solar system's diary. They're time capsules holding secrets from billions of years ago. Oumuamua might be a similar relic, but from another star. That connection makes it even more tantalizing. As I stand here in the observatory, surrounded by data from distant worlds, I can't help but feel we're on the cusp of something bigger. What does Oumuamua's visit mean for us? So what was Oumuamua, a cosmic rock, a frozen fragment, or an alien probe? We may never know for sure, but that's not the point. Oumuamua taught us to question, to dream, and to push the boundaries of what's possible. It reminded us that the universe is vast, mysterious, and full of wonders waiting to be explored. Here's the lesson: embrace the unknown. Whether you're a scientist chasing a cosmic mystery, a student gazing at the stars, or just someone curious about the universe, let Oumuamua inspire you to ask big questions and seek bold answers. The next interstellar visitor is out there and humanity's ready to meet it. Thanks for joining me on this cosmic journey. If you love this, hit that like button, subscribe, and let's keep exploring the universe together. What do you think Oumuamua was? Share your thoughts below, and until next time, keep looking up.